In this video, we're going to explore inverse relations or inverse functions. We're going to learn how to create inverse functions from a given function, and I'll also talk about what they look like in terms of their points and plots and graphs. So what is an inverse of a function? Functions are equations that let you plug in values of a variable, and then they give you values of another variable, just like all the x and y equations that we've been using this whole year. The inverse is like switching a table of values. So if you were given a table of values like the function here, if you wanted to do the inverse of this function, all you'd have to do is just switch. So instead of the -2 being for an x, now it's for a y. Instead of the 4 being for a y, now it's for an x. -1 is now a y, +1 is now an x, and so on and so on. Switching these is one way to actually create the inverse of a function. What does this look like when you graph it? Well, let's just plot the points, and then we can take a look and see what functions and inverses of functions look like. I'm going to plot the first one in green. -2, +4. -1, +1. 0, -2. 1, -5, and 2, -8. This line, this line here is our original function. And now let's take a look at what the inverse, I'll put that one in red, would look like. We have +4, -2, 1, -1, -2, 0, -5, +1, and -8, +2. And we draw a line through these points. And these are what the inverse of functions look like. They are not actually, it's not like they're perpendicular or anything like that, but this is what inverse linear functions look like. We can also create the inverse of a function when it's given to us as an equation. The way that we do this is, first off, we switch the x and the y around, and then we resolve it for y. So take a look at this equation, y equals 2x plus 1. First, I'm going to switch where the x and the y is. So now it says x equals 2y plus 1. So that's step number 1. Step number 2 is resolve it for y, get y back alone. So the first thing we're going to do is -1 on both sides. And then we're going to divide by 2 on both sides. So our final equation for the inverse is y equals x minus 1 over 2. So it looks a lot different than what it started with, but if you notice, all the operations are exactly the opposite of what they started with. When I first started it, I had a plus sign, now I have a minus sign. Right here, it says multiply, but now it says divide. So it's the opposites of whatever we had before. But we need to make sure that we do these 2 steps so that when we write it the right way. Let's try one more. Again, switch where the x and the y is. Now it says x equals and 3y plus 5. Now we solve for y. Get y by itself. First step is -5. Now it says x minus 5 equals 3y. And now we divide both sides by 3. Making sure that when we divide the left side by 3, we divide everything by 3. Not just the 5, not just the x, but everything. So our y is equal to ax minus 5 over 3. So what about when a function uses the function notation f of x? The way that we note what the inverse is versus what the original function is this little -1 right here, okay? It's f inverse. That -1 is not an exponent, okay? Okay, it's not an exponent. It's a symbol that means inverse. Okay, so when we want to do a inverse when written in function notation, it's going to be helpful for us to actually put a y in here. I wouldn't want to switch the f of x and the x doing something wacky like this. This makes no sense because we know that f of x is a notation, it's not a variable. So we need to actually substitute f of x with a y. Now this function has an x and a y that I can switch. And now I can start solving for y. Add 3 to both sides. Divide both sides by 2. And now the opposite of the cube is the cube root. Be mindful that we are taking the cube root to everything on the left-hand side. All right, so now we have a y equals x plus 3 over 2 to the cube root. Notice that this actually does mean that there is a root on the bottom, a root of 2. So we are going to need to split this up. And now we're going to need to work on getting that root away from the bottom, meaning we need to rationalize it. Remember from previous lessons, we want to make the exponent on the 2 match the root. We have a root of 3. The exponent right now is actually a 1. So the 2 that I'm going to choose needs to have an exponent of 2. So I can add 1 and 2 to make 3. Now they'll actually equal 3 and cancel each other out. What we do to the bottom, we also do to the top. 2 squared is 4, and 4 times x is 4x. 2 squared is 4, and 4 times 3 is 12. We still have the root on the top. So let's put our y. So now that we have our function, we don't need to put our y. Remember, we want to write it as f of -1. So let's put f -1, which means inverse of x, equals cube root 4x plus 12 all over 2. So we're combining a couple lessons in order to do this, but the switching and the using a y for f of x is the most important part about this example. Let's try 2 last examples to make sure we understand this. Again, we have an f of x. We need to switch x and y, so let's turn this f of x into a y. Now we're going to need to switch them. So I switch where the x and the y are. Now it's time to solve for y. First thing I have to do is get rid of this square, this exponent. The opposite of that is square root. What we do to one side, we do to the other side. Now we have a y minus 1. Be careful, we took the square root. That's an even root. So that means we get plus or minus square root x. Even though we have a root sign, we need to put the plus and the minus. Now we're going to add 1 to both sides. Notice how I write this final answer. I have my y equals Now, I do not really want to do this. Here is a mistake that students make. Because some students, when they write it like this, they accidentally make the radical sign a little too long. This makes the 1 underneath the radical sign, but it never actually was. So that we don't accidentally make that mistake, let's put the positive 1 first, then the plus or minus, then the square root of x. Now no one's going to doubt that that 1 does not belong underneath the square root sign. Let's now write our final notation. The inverse of f of x is equal to 1 plus or minus square root x. If a problem starts with f of x, you want to make sure that you end it with f of inverse, negative 1 of x. Don't end it with y. Let's keep it in function notation. Let's take a look at the next example. Again, substitute a y for f of x. Now let's switch x and y. And start solving for y. First up is the 2. Let's minus it from both sides. Now let's get rid of the exponent by doing the cube root. A couple things to notice right now. This time on the left-hand side, we have an x and a minus 2 to cube root. So we do actually keep that negative 2 underneath this time. I'm also not putting plus or minus because you don't need that, and don't put that when you do a root of an odd number. 3 is odd, so we don't put plus or minus. Now let's go ahead and minus 4. Again, I don't want to accidentally confuse people by putting the negative 4 after the root sign, so let's put the negative 4 first. Since there's no plus or minus in front of the root, we're just going to keep it at plus because there's no negative either. Cube root of x minus 2. Let's write it in the correct notation, our function notation. And this would be our answer. Okay, as always, if you have any questions, please leave a comment or email me. Otherwise, I'll see you back in class.